Hello everyone. In this video, I will explain how to find out the candidate key on a relation. Okay. So let us take an example. That's why we can easily understand. Here, this is an R relation. This relation is having four attributes. Relation means in RDBMS, a relation is a table. Table is having four columns. Columns are nothing but attributes. Now, this relation is having some of the functional dependencies. Those are A to B and B to C. These are the two functional dependencies on this relation. So now we are finding the candidate key. Find the candidate key of this relation. Candidate key of this relation. And before going to find the candidate key, so what is key? Key means key is an attribute or multiple attributes. If we are taking as a single attribute as a key or multiple attributes as a key. Key is a unique identification of this table. Uniquely identify the row in a table. So that is called a key. Key is either attribute or multiple attributes. You can consider as a single attribute or multiple attributes. So that is a key. And one more thing is before going to finding the candidate key, so first of all we should know how to finding the super key. What is super key? Super key is the maximum number of attributes are considered as a key. So that is the super key. And what are the maximum number of candidate keys? Maximum number of super keys. As for first we should take what is the super key. This is the super key. Maximum number means the complete all the attributes are participated in this closure. This is a closure. Closure is nothing but it is a set. The set is determining all the attributes in the relation. A is determining A, B is determining B, B can determine B itself, C determine itself, D determine itself. So that's why this closure is giving complete table, or this closure is giving determining the OR relation. So that's why this is called super key. This is called super key. And is there any other super keys are possible or not? Let us check. How to check the other possible super keys? So let us take the subsets of this set. So if you write the subsets, those subsets are also super keys. So let us check whether those subsets are super keys or not. How we can find that super key? So those subsets are determining complete this R. In that case only those are the super keys. So let us take one by one. What are the ABC is one of the, this is one of the subset. This is one of the subset of this closure. And is it determining? A is determining A, B is determining B, C is determining C. But this A, B, C, any one attribute is not determining D. That's why it is not a super key. You should remember. It is not determining complete R. R means it is having four attributes, but this closure is giving only 3 attributes. That's why it is not super key. And next one is, should take the next one, ADC, and BDC also. ADC means A is determining A and A is determining B also, because this is a functional dependency. So B is in the functional dependency, A is determining B, that is given in the question, and C is determining C, and D is determining D. That's why it is a, this closure is giving the complete R table. That's why it is a super key. This is a super key. And let us find out the next. BDC. This is BDC. BDC means B is determining B, D is determining D, C is determining D. But these three are not determining A. That's why it is not super key. It is not super key. Next. Is there any other combination of 3? ABC is completed, BCD is completed, ABD. ABD. This is also one of the subset of this closure. A is determining A, B is determining B, B is determining C. This is comes from functional dependent. The functional dependent B is determining C, and D is determining D. That's why ADB is also super key. This is also super key. Just draw a rectangle, whatever closures are super keys. Next, is there any other possible? BCD is completed, CDA is ADC. ADC is completed. Yes, ADC is completed. BDC. Next one is AB. AB is also one of the subset of this. AB is determining all. A is determining B, B is determining C, but AB is not determining D. That's why it is not a super key. Next, BC. BC closure is also not a super key. B is determining B, C is determining C. But these two are not determining A and D. And next, AD. AD means A is determining A is determining B, B is determining C, and D is determining D. These B, C two are, A is determining B, and this B is determining C. That's why A is determining B and C. Okay, so it is also super key because it is giving complete attributed list. Next, AD is completed. Next to BD. BD is not giving because B is giving B, D is giving D. And CD. CD is also not a super key. C is giving C and D is giving D. There is no super key. So next, is there any other subsets of this super key? Some more subsets are there. Single A. Single A is also subset of this set, but it is not a candidate key. It is only determining A, B, C, and this is only determining B and C. C is determining only C, and D is determining only D. Okay, these are not these are not a candidate keys, right? Next, what are all these are possible subsets of this closure, and what are the subsets are super keys. So let us here draw the super keys. A, B, C, D. This is the super key, and the super key subsets are A, D, C, and A, B, D, and AD. So these are super keys, right? And this one is having AD. AD is a subset of this one, right? And this one also AD is a subset. And this AD is also super key because AD is a super key. First one is, let us take this one. This is the super key. And these are the subsets. Subsets, all these are subsets. Subsets are also super keys. And now coming to this subset is again, these two subsets are again subset. Those subset is also super key. Now we here, what I am telling here, if a subset, also if a superset is having some of these subsets, those subsets are also super keys. So those super keys are not candidate keys. Which subset is not a super key? Those super key is called a candidate key. For example, this is a super key, this one is a super key, and this one is a super key. ADC, AD, BD. These three are the subsets of ABCD. That's why this super key is not a candidate key because the superset subsets are also super keys. That's why it is not a candidate key. You should remember how to find here. I'm telling how to find out the candidate key. Candidate key means candidate key is also super key. But what I am telling here, that super key does not having the subset. That the subset is not a super key. Okay. So which superset subset is not super key? That is called candidate key. And here this is having three: ADC, ABD, AD. ABC, ADC, ADC, ABD, AD. These three are the subsets. But this is again having subsets, and as well as these are super keys also. Again same, check the condition. So what is the condition? This super key subset is a super key or not? Yes, it is also super key. This superset subset is super key or not? Yes. But this super key subset is not a, what is the subset? A subset list of this key. AD and A single and B single. Single A and single D are the subsets. But these two subsets are not super keys. That's why this AD is candidate key. It is a super key as well as it is a candidate key. So why I am telling this super key is candidate key means this super key subset are not super keys. That's why it is a candidate key. This is the traditional way to finding the candidate key. Candidate key means it is also super key, but this super key subsets are not super keys. So that type of super keys are called candidate key. And you should remember one more point, that is candidate key means minimum number of attributes or considered as key. So here this is 3. Here three attributes are considered as key. Here also 3, but here only 2. Is there any single attribute is considered as a key? No. There is no single attribute is determining all the attributes of our relation. Okay. What is the minimum number of, which key is having minimum number of attributes? This key is having minimum number of attributes. this key is having minimum number of attributes. So that's why this is called candidate key. This is a candidate key. I hope you clear how to finding. This is the traditional way how to finding the candidate key. And there is a shortcut. I will tell you how to create the shortcut. Wait a minute. Let's save this. So what is the shortcut key? Here candidate key. First we should write the relation. Relation is A, B, C, D. And functional dependencies are A to B and B to C. Right? Now here how to finding the candidate key. So there is a shortcut. This is our relation A, B, C. Wait a minute. Okay, next. Here relation R. R is A, B, C. And functional dependencies are A to B and B to C. Right? So we should remember one thing. And here the total number of attributes are A, B, C, D. So which attribute is not present at right hand side, that attribute should be a part of candidate key. So what is the first step? So candidate key, which attribute is not present at right hand side? Which is not present? D is not present. That's why D is one of the part of the candidate key. And one more thing, let us check whether one by one. D with combination, D with A. First candidate key means minimum. That's why we should take the combination of D with other attributes AD, BD and CD. Is these three are the possible combinations. So these three are not a candidate key. Let us take another attribute. Otherwise we will check these. Right? First AD means A is determining A is determining B, A determining C and A is determining D is determining D. A is determining A, B, C because these two functional dependencies are telling A is determining B and B is determining C. That's why AD closure is determining all these. And BD means B is determining B and B is determining C, just only D. And C means CD only. So that's why what is the candidate key here? Here there is a combination. Two attribute combination is determining all the attributes. That's why minimum attribute list. What is the candidate key definition? Minimum number of attributes are considered as a key is called a candidate key. That's why AD is a candidate key. AD closure is a candidate key. If it is not determining all this, again we need to check the next one. ADC and BD, ABC, next one. But we don't need to calculating or finding these super keys because candidate key means minimum number of attributes. I think you should understood this. You understood this one. How to finding the candidate key. This is a shortcut. how to finding the candidate key in shortcut way. Just we are only taking which attribute is not present at right hand side, that should be take first. Then this attribute, not only single attribute, we can find more, one or more attributes are not presented at right hand side. So just you should take the not present, you should take the attribute which are not presented at right hand side. Then next we should make some combination of with other, we should make the combination of this attribute with others, AD, BD and CD. And these three, in these three, which one is generating complete table, complete relation. So that is the next step. So this is very easy to find and this is a shortcut way. Okay, and one more thing is this relation is having one or more super keys, as well as a relation is having, relation has one or more candidate keys also. But here in this relation is having only one candidate key, that is AD closure. This is the candidate key and this is only one candidate key, there is no other candidate keys. And in the next video, how we can find the multiple candidate keys. Okay, so in the next video I will take another example and we will see some other examples also. We will see more problems for practicing. Thank you.